All right, so today I've got some questions on multiplexers and decoders, both because you might not have studied them much in 2741, so you might want to review on them. And then also it's a way to kind of practice some Verilog, because very soon, probably next week, if not next week, the week after that, you'll be doing a lot of Verilog, and so it's good to get in the habit of doing that. Before I do that, since I have some limited time, do y'all have questions on the homework, or is there a problem like the homework, one of the homework problems you'd like me to do one like one of them?
I have a question about the Verilog for the homework.
Okay, let me see which, let me just pull that up.
It's just like a general question.
Okay, what's your general question?
It's like, I can show it to you. It's
Okay.
with the, for the case statement, like whenever you have the 0, 1, 2, and 3, like what are those for? Is that saying when U is 0, when U is 1?
Yeah, so I'll show you what that's for.
Okay.
So, is that your solution on that one? Or is that, does
no,
that give you,
that's saying draw a circuit.
Okay, so, let's see. Okay, yeah, so let me explain that. And that's good because it relates to the stuff that I want to do today. And this actually works very well with today's problem. So I'm going to use this as an example for a type of problem. Let me... Okay, so I'll do one similar to this. I will have module Avogadro. That's my cat. He used to be my cat. He's not with us anymore. S T U1 U0 G, and then you would have your inputs, and I'm not going to type all those out, but you've got your input and you've got your output. Now, just so you know, the reason the output is reg is because we're assigning reg inside an always block. Whenever you assign a value inside an always block, it needs to be declared as a reg. And then we have an always block, always at, and then this is called a sensitivity list. What comes after the at, S, comma, T, comma, U1, comma, U0. And what the sensitivity list tells you is anytime one of these variables changes, do what's inside this always block. And then we start with a case statement. So what a case statement is like a it's like an if, then, else, if then, else, else. You can have like lots of different possibilities. And so what's in the curly brackets here, we have U1, comma, U0. What the curly brackets do is concatenate, so U1 is a bit, and U0 is a bit. So U1, U0. Well, what if rather than treating each of these as one bit, I want to treat this as a 2-bit number? Well, then I can do that by putting them in these curly brackets, U1, comma, U0, and then that says treat this as a 2-bit number, so it's now treated like 0, 0, 0, 1, 1, 0, or 1, 1. And so this, what's inside the parentheses inside the case is saying whatever this is, that's what the case statement is looking at. So I'm going to change this to be 0, colon, G equals 0, 1, colon, G equals S exclusive or T, 2, colon, G equals not S and T default G equals 1. And then you always end your case with the end case keyword. And do me a favor, if you ever want me to help you with your Verilog, which I will try to do, the neater you can make your Verilog, the easier it is for people to help you with it. If you don't indent, and if you don't, if you don't make your blocks like all even, it's so hard to figure out what's going on. So end case, and then end module. Okay, so what the case statement does, it says, based on the value of U1 and U0, do different things. So this is saying that I'm going to have a multiplexer. So I'll have a multiplexer, and it's a 2-bit multiplexer with U1 and U0 being inputs into my multiplexer. They're my select values. And then based on U1 and U0, that's going to be what my output is. Now, with a case statement, if you don't have a value for every number, which happens sometimes, like if you have don't cares, you need to make sure you have a default to say what the value is in a default situation. Now, here, the default, I'm going to put it, well, we'll get there in a second. So if U1, so the way a multiplexer works is the value of the multiplexer is whatever is coming into this input when U1, U0 is 0. So if U1, U0 is 0, 0, then G equals whatever is coming into this 0 input right here. So I want, when U1 equals 0, 0, I want G to be 0, so I want 0 to go there. Now I need 1, what's coming into the 1, to be the exclusive OR of S and T. And what's going into the 2 needs to be the not of the AND, well, that's a NAND. So I need that to be the NAND of S and T. And then as default G equals 1, I could, the way I would have to set that up on this circuit is 1. That you would have that, like, various different reasons why you might have that, but that means since it's not defined anywhere else, I would need to have a 1 right there. If you need something, it is probably best just to, so I'm talking to my Zoom person, probably just to yell out. I will turn on the chat, but I often don't see it. But I'll try to pay attention to it, but I often don't notice it. But can you hear me okay? I do have the chat open now. Does that mean you can't hear me? Am I muted? No? Oh, okay. All right. Okay, so did that answer, that was a very long answer to your question, but I used it. Okay. Oh, good. It was a good answer.
I appreciate it.
Okay. All right. So now let's look at problem 1. Actually, before I do that, let me ask you, Michael, do you have any questions that you would like me to answer before I do the worksheet? Because I went over homework kind of stuff last week, so if you have a specific question on the homework, I'd kind of want to get to that first. Oh, you don't have a mic yet. Okay. You can hear me, but no computer screen? Oh, I'm not sharing my screen. Thank you. Okay, yeah, good. Right. Okay, now can you see my screen? Okay, now what I just did was there was a question on what does a case statement do, and so I just did a problem that was like the problem on your homework that had a case statement in it, and so if you wanted to get a screenshot of that, I just was showing how it worked. So that's what I did, and now I'm doing problem 1 on the worksheet. Okay, so we're supposed to write behavioral Verilog for a circuit with the following behavior. So when S equals 0, the output is G equals not X. When S equals 1, the output is G equals X. And so this describes a multiplexer. So it doesn't say to draw the circuit, but let's draw the circuit. So it's a multiplexer. It's a 2-to-1 multiplexer. We'll have an input S and 0 and 1, and we also have X, and when S is 0, G is not X, and so into the 0 input of the multiplexer I put not X, and when S is 1, then G equals X, so into the 1 input of the multiplexer I put a 1. So that would be the circuit that you would draw. So very simple multiplexer. And then our Verilog will have module, you start with module. And you'll give it some kind of name. I'll call it module problem 1. And then you have to say your inputs and outputs. I have 2 inputs, S and X, and 1 output, G. And then I'll say which are my inputs. So input S comma X, and my output is going to be a reg. And the reason it's going to be a reg is I'm going to change it in an always block. With multiplexers, there's different ways to do multiplexers. I like to do them with an always block and a case statement. You can do them with, in this one, since we only have so few things, I'm just going to use an if statement instead of a case statement. There are other ways to do it, but this is the way I like to do it. And so then I'll say always at, and then what do y'all think we need to put in the sensitivity list? S and X. And then, if I'm going to have more than one statement in here, I need a begin and an end. But this is a very simple one. All I'm going to have is an if statement. I'm going to say if S is 0, G is not X, else G is X. And that, even though it's an if else, that's still just one statement. So I don't need to have a begin and an end. So if I had more than one statement, I would need a begin and an end. But so I can have if, and I have 2 ways I can do this. I can say if S equals 0. I need to have the 2 equal signs because that's what you use when you're comparing things. Or I could have if not S. Either one of those is fine. Those mean the same thing. If not S, then G equals not X. Else G equals X. And with my if statement and my else statement, I also didn't need begins and ends because I was only doing one thing. If I was doing more than one thing in these, I would have to have more than one. Sometimes you have compound if statements. Like I might have, like if, if not S, do this, else, and then I might have like a branching decisions, like I might have two possible different things if S was one. I mean, I guess I could have something like, I don't know. But if I had another branch here, then I would have to have a begin and end on my else statement. But I don't, so I can leave it like that, and then I can end module. Okay, so that's your basic setup for a multiplexer. A lot of times, instead of an if statement, we're going to have a case statement. So I'm going to stop this and save what I've done so far, unless y'all have questions.